In this video, we're going to look at two simple physics type problems of how we can actually calculate the amount of work that is done by a constant force. So here when we think of the word work, it's a little different than kind of our normal definition. Here we're looking at the formula for calculating the amount of work done based on a constant force is going to be the amount of force in that direction multiplied by the distance. So here we have work is equal to the force multiplied by the distance that we have moved some particular object. So this is the formula that we're going to be using. And the first question states, determine the work done by a crane that is lifting a 2,400 pound car 5 feet. So if we have, here's our car that is 2,400 pounds. And if we're going to lift this straight up, then we want to figure out, here is the force, okay? And then what is going to be the distance? Well, they tell us the distance here is 5 feet. So we want to move this car a distance of 5 feet. So here, the force that's needed for this example, we have the 2,400 pounds. And this one's going to be kind of straightforward because the amount of work, remember, is the force times distance. Well, the car is going up by the crane, and that's the direction of the force. So the force that's going in the direction that we're moving, so work then is equal to the force of the 2,400 pounds multiplied by how far we move the car, and it says we're going to move it 5 feet. So this is simple enough that we would take 2,400 and multiply by 5, and we get 12,000. And the units here would be 12,000 foot-pounds because we're taking feet times pounds. So the unit for the 5 is 5 feet. The force is pounds, so this is referred to as 12,000 foot-pounds. So the force that we're using is the force that is going here in the direction that the car is being moved. Okay, so this one was easy enough because all the force was in a vertical direction. There was no force going horizontal. So it's just straightforward, 2,400 multiplied by 5. Now, the next example is going to be a little bit different. Here we have a ski patroller is going to pull a rescue sled across a flat snow surface by exerting a force of 35 pounds. So here we have a force of 35 pounds on a handle that makes an angle of 22 degrees with the horizontal, and we want to find what is the work if we pull the sled 200 feet. So if we're looking at our formula where work is equal to force times distance, well, we know the distance right here is 200 feet. So the only thing else we need to find is what is the force? Well, if we have a person here that's pulling this sled, let me draw a quick sketch of this. Here's our rescue sled, and there's a handle on this. So here's the handle, and they tell us that this handle on the sled is going to make an angle of 22 degrees. So this angle here is 22 degrees, and we're pulling this with a force of 35 pounds. So this vector here, this is our force here of 35 pounds, and the sled is moving a distance of 200 feet. So here we're going to go from our sled is going out a total distance of 200 feet. Okay. Now, as our person here, and let's see, we'll draw a little person in here. If we're standing here and we're pulling on this handle, we're pulling this with a force of 35 pounds. Now, all of that force is not pulled in the same direction. Because of this 22-degree angle, some of that force is being pulled horizontally, okay, and some of it is pulled vertically. So in other words, part of that force here is pulling up over here, and then the other part of the force is going horizontal. And the force that we want to use here for this is the horizontal force, because that's the direction that the object, the sled, is moving. So we'll call this force, and I'm going to call it little sub x because we're looking at the x, whereas this over here could be the force that is in the y direction, but we want the horizontal. So if we think about this carefully, what trig function is going to deal with our 22-degree angle. So the force we want here is the adjacent side. The 35 would be the either the r value or the hypotenuse. So what trig function deals with adjacent and hypotenuse? And that would be our cosine. Cosine is equal to x over r, or we could think of this as adjacent over hypotenuse. And if we multiply by the r, that means we would get r cosine theta is equal to x. In our case, the x we're talking about would be this f of x. So if we find that, our r value then is 35 times the cosine of the angle, which is 22 degrees. This is going to be equal to that force in the x direction that we're looking for. Okay? So we need to take this amount and multiply that by the distance. Well, the distance we're moving this is 200 feet. So therefore, if we're trying to calculate the amount of work, that's going to be equal to the force, which is going to be the 35 times the cosine of 22 degrees, multiplied by the distance we're going to move this sled, which is 200 feet. So if we enter this into the calculator, we would have 35 cosine of 22, 35 times the cosine of 22. Now make sure your calculator once again is in degree mode, and then we're going to multiply that by the 200 feet. And we get 6,490, and I'm just going to round that to the nearest whole number. So 6,490. And again, here we're talking about feet and pounds, so this would be 6,490 foot-pounds. So that's the amount of work that is done by pulling with a force here of this 35 pounds, which means the horizontal is pulling at a force of the 35 times the cosine of 22. And let me put that in. If we were to take simply the 35 times the cosine of 22, we get roughly 32.5. So that tells us that we're pulling here at a force of 32.5 in the x direction. Okay, so that means the amount of work that we would calculate would be 6,490 foot-pounds. So here we have just two simple problems dealing with how we can calculate work by simply taking force times distance. And just remember that the force that we're looking for is the force that is in the direction that the object is moving. So when we looked at the car, the direction the object was moving was straight up because the crane was lifting the car straight up, and because it was a 2,400-pound car, the force was simply 2,400 pounds. So therefore we get 2,400 times the distance of 5 feet. And the example down here with the sled, because we're pulling this sled, we have a little bit of an angle here of 35 pounds, then we're only looking at the force in the x direction on the horizontal because that's the direction that the sled is moving. So therefore we would calculate that by using our trig function, the cosine function, and that would give us the force in the x multiplied by 200 to get the 6,490 foot-pounds.